Okay, so the second break for today. We're ready for our first example, our first actively doing something. And all that talking was a bit unusual for this class. For this class, it is an active subject. We are mostly going to be doing stuff. That's why today is a little bit longer, a 2-break day. And most days, there's not going to be that much talking before we get into the programming part. And we're going to be using 2 programming languages this semester. The course is about algorithms, developing logic, learning how we have to think in order to feed instructions into a machine, because machines do not process in the same way that humans think. So we have to, and machines cannot adapt. We're the intelligent ones, so we're the ones that have to adapt. So we have to learn how to adapt our thinking to feed instructions into a machine. So for the most part in class and the assignments I'm going to pay more attention to when I grade and try to decide what parts need focused on, we're going to be looking at Raptor, which there's a thing about installing Raptor. We looked at it very briefly. Seems like a long time ago now with this really, really long class. Most of our days won't be this long. We put together a picture of a flow chart, and then the computer can run through that as code. The computer can also generate code from that as well. We'll see that here in just a second. But our textbook, this one that was selected by a statewide committee, happens to have Python included in it. Like, it has a Python interpreter. In the ebook, you can actually run Python code there in the ebook. I guess that is one definite advantage over paper books. You can't run code in a paper book. So Python is the most popular programming language in the world, so we wanted to include that. But we're more focused on algorithms here. And this day has already been really long, so I don't think we're going to look at any of the Python stuff until Monday, which means any assignments related to Python, I can push back the due date on until after we've talked about them in class. So as you get ready this weekend, look at the setup instructions, maybe start reading some, but anything that's going to want you to do stuff in Python, you can wait until after we've talked about that in class to work on. But for us, we're going to look at Raptor. That's what our first assignment here is introductions. And we're going to use Raptor to put together a small program. So a standard introduction board in module 1 is introduce yourself. But you all know how to type a paragraph, and with what this course is about, we can do better. So instead of introducing yourself, you're going to write a program that introduces you to your classmates. It doesn't have to be fancy. You can see in my little example here, this was from a couple years ago because I'm 43 now and might have got my age wrong when I wrote it. But you feel free to refer to yourself in third person, because remember, it's the program introducing you. So I or me would be the program. But you'll want to store some data points and then print those out. So that's the first thing I wanted to look at in Raptor, is how we do that. And kind of click around and look at some different buttons. Get you started, because it's an active subject. We learn best by doing here. And that means that this weekend, what I'd like you to do is just click around on Raptor, look at where the buttons are and stuff like that. So when we do this, let me get the other stuff out of the way. Sunscreen. Okay, so there's 2 parts here. When you open it up, you probably have this little thing here says Master Console, and then the section here that has the.
It seems like I can't get it on my Mac.
It can be a bit problematic on Macs. That remote access that's what I would recommend. I've got it running on a Mac, but there's a whole bunch of steps to do it. It's a lot easier just to remotely access the school's computers and do that there. Will you be able to do that, Keegan?
Okay.
If you go to modules and video lectures, at the very bottom is instructions for remote access. We looked at it earlier. That was just a reminder of where to find those. But that'll probably be your best step. And I guess if you want to watch now, then afterwards, you can remote access into the school's machine and use Raptor there without all the 6 necessary extra steps to install Raptor on a Mac.
And so for the installing Raptor, how would you just like screenshot that and just, you know?
Oh, you'll have a file. So it'll save a file. Let's look at the buttons. So right up there on the first button, you'll see the new and save. So just save that file and then you'll send that file to me. And then
Cool.
I'll actually run your program when I grade it. And if you're doing the remote access thing, make sure you do that before you log off. Because depending on what security or network classes run, those computers might be frozen. So that if they completely destroy it software wise, all they have to do is power down and reboot, and then it's like they never logged on it the last time. So those are specific School of IT computer labs. So sometimes we might need to break stuff in order to learn better. So those labs are set up for that. So make sure you retrieve the file first. Just email it to yourself or something. But it can be made to run on a Mac. It's just, there's a whole bunch of steps. So it's a whole lot easier just to remote access a computer that it does run on.
Yeah, it says it couldn't do it because it was from an unidentified web developer.
Oh, well, it should be identified. Raptor was made by the US Air Force.
Yeah,
that
but
might be the Apple thing. Yeah, that Mac security has been driving me crazy lately. The latest update, it actually undoes that. So all the software that I put on there that I had to override that, you just go in system preferences and there's a checkbox, but it rechecks that. It redoes that. And it's like, oh, you didn't buy this from the Apple store. So it blocks.
Yeah, that's what it said. That's what it said. Didn't buy it from the Apple store. And, you know, but luckily, when I downloaded my Chrome, when I got the Chrome package, like that was with the school, and then also, you know, just it was a free download.
So we can try those alternatives. If you have any trouble with that, I can help you do that. But.
So I was able to get my Chrome when I first got my first school and everything. And so, you know, just with any other, you know, downloads that I try to have, it's like if you didn't get it from the App Store, or you know, if you
it's Apple. Microsoft does the same thing, but it's easier anymore. They're trying to do the same thing. It's easier to override Microsoft's.
Yeah.
But yeah, just like Apple, they will charge you for free software.
And then also it's the same thing. It's the same thing with Google applications. Like I have a Mac, but you know, I don't have a Chromebook or anything, but it's like if you don't get stuff downloaded specifically from Google and Apple, then
for your class, for this class stuff, if the MacBook gives you trouble, just try remote access those labs. If you have any trouble, I can help with that. So this is what our software is going to look like that we'll be using for that. You can click through the buttons and see. We can kind of zoom in and out. I'm going to start here on window because it's real small. So tile horizontal puts our little output stuff down here at the bottom and the window up at the top. I prefer it vertically. So now we have enough room to work. So go to window and tile vertically, and then it'll put your output over on the right hand side. But you can resize those, set them up however you like it. There's different zoom in and out. I'll zoom way in so y'all can see it on the screen share. Different things you can turn on and off. You can click through the buttons. Run buttons is an important one. We're going to draw a flow chart, but that flow chart can actually run as code. And more than that, you'll notice there's also a generate button. So we can actually take our flow chart and export it into any of these programming languages. Nobody's really bothered to mess with this in a while though, 20 years or so. So Ada and VBA aren't used very much anymore. C# and C++ are still the same. We're probably 10 versions later on Java than what that actually exports to. But the standalone, that's the executable. That's the .exe file. So that just runs your standalone executable. So you can generate a regular program afterwards, which can also be helpful in learning those other languages because you can put the flowchart together and then generate that and see what other types of text-based code look like. So we have some run buttons, pause, stop. The step is very useful. So we can run it one block at a time or all of them at a time. This little slider here controls our speed. How fast do we run through the program? So while learning stuff, we'll probably want it kind of slow. That way we can see it going step by step. And earlier, when we were talking about data, one of the things that came up way back in prehistory, or that transition from prehistory to history, we had pictorial languages, right? Because that works really well for humans. We have, instead of representing our sounds, which only really work for people that make the same sounds as us, we draw a picture. And in our modern world, parts of IT can be an international project, right? This might be international. So there is an international standard of communication for information technology. And some fields do a lot more international communication than others, right? So like a programmer working for Google, you might be part of a team where some people are in California, some people are in Hamburg, some people are in Beijing. That's not a very good example because people in Hamburg and Beijing would both speak English, but hopefully the point's there. Maybe some people in Africa and Japan, but you might be working with a team around the world where you don't all speak the same language, versus somebody that does IT support at an office here in Louisville, here near Louisville. You're probably not going to be doing a whole lot as much international communication, but there is a standard, and it is a pictorial based one. So a couple of our big ones, a rectangle represents the volatile storage. Oh, Raptor will make you save after a minute. I always forget to do this. So when we want volatile storage, that's a rectangle. And to put it in there, is click and drag it over, or you can highlight it over here in this section and just click it where you want to put it in the flowchart. Whichever way makes more sense to you. There's also some right-click options. You can add comments. Comments are bits of code that don't do anything, but help for documenting it and keeping track of what's going on. A rectangle is the symbol for volatile storage, which we're going to call variables. You might recognize that word from math class, but it is not at all like a math class variable. In math class, a variable is something we don't know about. And in programming, which just preview of next week, a variable is a named location in memory. So we know exactly what it is when programming, but we'll talk about that next week. So a rectangle represents volatile storage. So we want to put some data in volatile storage. So for a program to introduce me, first thing I need is probably my name. Chris. So when you double click on that symbol, you get a little box like this. What are we going to set? We need a way to refer to that. Right? We're going to talk about this next week, so a bit of jumping ahead here. But the computer is going to remember this data based on which bits in RAM it stored it in, which a human will never keep track of. Right? We'll never remember that this data is stored at bit 83,214 over in the RAM chip. So we need something useful to refer to it by. So we give it a useful name, and then we're going to set that name to store a piece of data, a number, a Boolean, which is a true or false value, or a string. And that's our term for written language, basically. A string of characters is what it stands for. And when we have a string of characters, notice I put quote marks in there. We have to explicitly say, it's like explicitly saying quotas on this data is Chris in this case, or whatever your name is. So anytime you want actual human written language, make sure you put quotation marks around it, because no quotation marks refers to our variable, refers to how we store things. And then quotation marks are the actual data. Kind of like saying quotas on that.
And this is how we're going to introduce ourselves.
Mhm.
That's it.
So you'll store a few data points about yourself. So with that volatile storage symbol, the rectangle, bring a few of those over. Let's see. So age, I'm 43 right now. Notice that a number does not get quote marks. So once again, how do we want to refer to this data? We need something useful so that we as humans can keep track of it. So some sort of useful word, and then a number is a number, so it doesn't need the quote marks. There's a difference. If we just wanted
Because it's a
symbol,
value. It's not.
Yes, we need the computer. We need the computer to do something with a number. Likewise here, there's no quote marks on those variable names because we need the computer to do something with them. But the data that we actually stored, like my name up here in this first example, we want quote marks on that because all the computer is going to do is either retrieve it or store it. The computer is going to move it around. It's not going to change it. Like, don't change our data. It's exactly quotas. This is the data every time. Whereas a number we can do math with. So no quote marks on that one. And you'll just save a few points about yourself. What's something else? Vehicle, which I think I misspelled. But that'll be okay because the computer doesn't know how to spell vehicle. As long as it's spelled the same way every time, it'll be close enough. Maybe I did spell it right. But that's what the assignment's going to be. You're going to store a few data points about yourself. And a data point is just a single item, like your name, the age, type of vehicle you drive, the program you're in at school, what degree are you getting, how long have you been in school, all the normal introduction stuff. Save those as separate data points. And then in that international communication language I mentioned, that's based off pictures, a parallelogram represents input and output. So I'll bring that down here and I'll add another comment, just keep that on the screen somewhere. A parallelogram represents input and output. And you'll notice these two parallelograms here in Raptor, they have extra arrows. So like one of them has an arrow coming in, one of them has an arrow going out to help keep what the symbol is. But we get a visual representation of what's happening. And then for our output, we need to piece together a string. So I don't have a full sentence here anywhere, right? I have like the subject of a sentence, an adjective. So like sentence, Chris is 43 years old. That has a subject, and I guess it's a descriptive term. It doesn't quite seem like a direct object, but it's probably some type of object because it goes with is. But I don't have a full sentence stored anywhere. I have to build a sentence up. And our term for that is concatenation. It's a big word. I wrote it out here. Concatenation means to take different pieces of a string and combine them into a bigger string. So in this case, first thing we want to do is grab that whatever's stored in that name variable. So we have some data stored in a place called name. So add to that the words is, and our symbol in Raptor is just going to be a plus sign for concatenation. Same thing with Python. Our symbol to concatenate two strings together into a bigger string of characters or more words is the plus sign. So these words plus these words plus whatever's stored in that age variable plus the words years old, period. So just adding a bunch of collecting the data and then adding pieces together to make a grammatically correct sentence. That's basically what your first assignment is going to be. I can do another output here. That'll fit on the screen. So once again, whatever is stored in that name variable, so I can change it. Maybe this program needs to introduce somebody else. Somebody named Sally that's 22 and drives a Toyota. Okay. Then we could just change what data is being stored, but we want the output, we want it to output the correct result. So that's why we store these values instead of just typing them directly. So whatever's stored in that name variable, plus the word drives, and notice that I added spaces there. I didn't just put drives, I put space, drives, and then another space, because the computer doesn't know what a space is. That's for humans. The computer doesn't know the difference between a space and the letter D. Those are just symbols that humans use. So if we ask for one, it's going to spit them back out. So that's when you're going to want to watch for as you write your program. Just make sure you get all the spaces in correctly as you concatenate things together. Chris drives and then whatever's stored in the vehicle, which I think I misspelled. Name drives a vehicle, and then whatever's stored in those data points is what gets brought out. And notice the program added an extra word. It put that word put at the beginning. But I didn't say the word put here. That's part of the instruction. That's the instruction that we're telling the computer to do. Put all of this stuff to the output, which the default output is our master console. So if I come hit run, I'm gonna turn this down real slow so you see it's going through one step at a time and then outputs those sentences, which are really small. So I'm gonna come over here, make that font size bigger. Oh, probably bigger than that. There we go. Hopefully big enough y'all can see it on the screen. And yeah, that's basically the first assignment. Does that make sense to everybody?
The first
You'll have a few
assignment,
more things to do. What was that, Keegan?
the first assignment is just put your name and then yours, how old you are, and
So whatever you want to do, whatever you would do to introduce yourself. So normally you would write a paragraph talking about yourself, right?
right.
So you just want to break it up. So take the subject of those sentences and store it as a variable. All of the verbs that you would do, store that somewhere, and then have the computer put sentences back together. That makes sense?
Yeah, then how would the program just put that together, the parallelogram?
Mm-hmm. Yes. So for this first one, all you need is the rectangles for volatile storage and the parallelograms for the output. And it'll print it right to the console. And then you want to keep an eye on things though. There are some requirements on there. There was a comment come up in the chat room about how long should it be? And there are some requirements we'll look at here in just a second. Oh, I think it's pulled up. Oh, nope, I closed it. So here in the discussion board one, so store 5 data points about yourself. So like your name, your job, what's your major here at Ivy Tech, different things that you would use, different data points about yourself for an introduction, and then use those 5 things to make at least 10 sentences. So it sounds like some of them are going to be used more than once and duplicated. So for example, your name's probably going to show up in every sentence that you put together. And more is okay. More will always be okay in my class if you go beyond that. If you decide you want more data points, Like, oh, there's more than 5 interesting things about me. I'm gonna make a whole bunch of data points. That is perfectly okay. And make sure you correct them. Like if we look at this output now, Chris drives a Jeep Patriot. Notice how it missed that space because the computer has no idea what a space means. It's also not a grammatically correct sentence because there's no punctuation at the end. We can just come back in here and edit that. So we need to explicitly tell the computer to put a space there and then maybe concatenate on a period. Again, quote marks for the things we need exactly to be there exactly. So if it's written language, you need quote marks around it. If it's a number you can do math with, you don't need quote marks on it. In this case, since we're just printing out sentences and maybe not doing a whole lot of math this week, to get started, it might be easier just to put quote marks around all your data. Just get in the habit of, because it wouldn't hurt if we said, okay, that's not the number 43 that we do math with, that's the symbols 43. Because then when we print it out, it still looks the same. And notice over on the left-hand side, so we got the output over here on the right on my screen. So whether that's an actual number or just the symbols representing that number, the sentence looks the same. Watch the spacing, make sure all the sentences look correct so you can go back in and edit them. And the thing you're going to watch over here on the left-hand side, this is called the watch window. As it runs through the program, notice how it keeps track of all of our variables and what's stored in that variable. That's one of our tools to debug a piece of software, make sure it runs correctly and stuff. So that's kind of the first assignment. And that's going to be my recommendation for what to do during lab time today. So still, 50 minutes left on our schedule. And this is an active subject we learn by doing. So on that first discussion board, put that together. And then once you have that ready, you'll take a screenshot of it. So if I come back over here, the best way to take a screenshot if you're on a Windows machine, you push the Windows key, Shift and S, and you get these little crosshairs where you can draw an image. I probably stopped showing the video when I was doing that. And then a notification usually pops up. Oh, where's my notifications? Well, when you do that, then a little notification will pop up and you can save it that way. The Zoom call always messes that up. I think if I stop the screen share, I might get the notification. Well, let me do this real quick. So Windows Shift S, and then you can take a picture of it. And now I got the notification back up. So let me share that. Oh, it went away. Share screen. And then afterwards, you get the little notification down here. You can click on that and you have options to save it. Sure, that'll work. And once you have that picture of it saved, make sure you can see your code and the output in the picture. Save it, and then you'll come over to Ivy Learn. And when you go to post, if anybody's new to Ivy Tech for using Canvas, if you've used other LMSs before, that's learning management software, you probably saw a button that said post with any discussion boards or something. But for any Canvas product, we have to reply to the instructions. So you hit reply. And you want people to see that picture. So instead of attaching the picture through a link, make sure you go to images and upload the image. You should be able to just drag it over there. Oh, I saved it at a place I can find. Yep. Just drag that over there, and when you submit it, it should show in the post. So make sure the picture is visible and just hit post. And when you reply to your classmates, you can just write the reply. Just the normal type up the reply. As for your people might be anxious to get started into this. I think I can go ahead and delete that. Oh, whoops. Pictures are in the way. Delete that. So just click reply to the discussion board and upload it. But basically, make a small program that introduces you. Save some interesting data points about yourself. Then concatenate those together in sentences and print those out. Does anybody have any questions about that first assignment? So all the assignments are due before next Wednesday. There's going to be a few more things. The Python assignments, we didn't get around to talking about Python today. So the due date on the first Python assignments will be pushed back if necessary. But also the first assignments are really, really quick. So after we talk about them on Monday, that'll be quick. So hopefully the assignment makes sense. If you have any questions, let me know. I'm always happy to help. But during our scheduled time, from now into 4:50, I'm just going to be sitting here ready to answer any questions if they pop up. So that was kind of it for today. A lot that we talked about, the course policies, went over the first bit of notes, some background information that gets us ready. And most of our classes are going to be more like that latter part there, the last half hour, where we're just actually working through something, actually doing something. Because it's an active subject. We learn by doing. So now is the time to do. Does anybody have any questions about the stuff we've covered today? Okay,
This is gonna be like uploaded, right?
yes.
So okay.
Yes. So the video will be available as soon as, yeah, here in just a second. I was counting down on my fingers, waiting to see if anybody had any questions. I assume the silence means no questions. I'm stop the Zoom recording. It usually takes about 20 minutes to process it or so. And then it will be on Ivy Learn. Oh, whoops. I clicked over there to point at something and forgot to share my screen. It'll be on Ivy Learn in two places. There's a link that says Zoom, so you can get to it there. But I don't have any control over that page. So under modules, I made a page called Course Zoom Room. I will also put the link there. And it usually happens about the weekend. I use YouTube for video storage because videos take up a lot of space and YouTube doesn't have any limit on it, whereas my local computer does. So probably won't be till the weekend, but the video will also be posted on YouTube by the weekend, and I will send out the links to those once I have them. But yes, the video will be posted. Any other questions? Okay, I assume the silence means no questions. So that was kind of a long day. Most of them will be shorter than this and leave more for the actively doing stuff part. But there was a lot to go over in the first day and getting started. Otherwise, if you have any questions, let me know. Text messages and Ivy Learn messages make noise on my phone. And from now to 4:50, I'm just going to be sitting here waiting for questions to come in. But you can ask me questions anytime. I'm always happy to help. I will get back with you as soon as possible. Anytime you ask a question. Otherwise, you'll have a great weekend, and we will pick up from there on Monday and learn more about programming and start putting algorithms together.
I do have one question.
Yes.
My one question is, where's the SOIT thing again?
Oh, I wasn't sure where to put that. So if you go to modules,
yeah, I'm on that.
Under resources and video lectures.
Okay.
It's at the very bottom because I wasn't sure where to put it, and I made a short video walking through the steps a couple semesters ago.
Okay.
But yeah, labs rooms 158 and 162 will have Raptor installed on them. Oh, and there's the
Already
temporary
will have
RAM adapter.
Raptor installed on it.
Mm,
They'll already have Raptor installed on it.
yes.
Okay,
in
thank you.
Rooms 158 and 162. Yeah, so they're ready to go. You'll want to set up your own account because these are temporary. He's probably going to shut them down next week or something.
Okay.
But when you log on, there's a screen, there's an icon there that you click, it says help desk, and then there's a button to set up an account right there.
Okay.
All right. Any other questions?
No other questions.
All right. Well, y'all have a great weekend. I will see you on Monday.
I'll leave this meeting. Bye.